Number 8. The CEO of a company that owns 4 resort hotels wants to evaluate and compare satisfaction with the 4 hotels. The company's research department randomly sampled 28 people who had stayed at any of the hotels during the past month and asked them to rate their expectations of the hotel before their stay and to rate the quality of the actual stay at the hotel. Both observations used a rating scale of 0 through 10, with 0 being as very poor and 10 as excellent. The researchers compared the hotels on the gap between prior expectation and actual quality. Using the difference score, y is equal to the performance gap or prior expectation score minus actual quality score, we want to first identify the response variable, the factor, and the categories that form the group. So, in this particular example, and I'm just going to type this on there, the response variable is performance gap. Since we were given directly in there that y was the performance gap, that being the response variable, the factor is which hotel the guest stayed at, or stayed in, I should say. And why is that? That's because there were the 4 hotels, and they randomly sampled a total of 28 people who stayed at any of those 4 hotels. So because of that, the hotel that you stayed in would be the factor. And because of that, the categories are the 4 hotels. Again, for very much the same reason as why the factor is the hotel as well. Meaning that it is that's the grouping or the categories that we'll be using for this ANOVA. We want to state the null and alternative hypotheses for conducting this particular ANOVA. So for this, we are going to have this particular ANOVA as the null hypothesis of all the means being equal. We have 4 groupings, 4 hotels, so this would be mu sub 1 equals mu sub 2 equals mu sub 3 is equal to mu sub 4. The alternative hypothesis is that at least 2 of the population means are unequal. So at least 2 of the population means are unequal. And now we want to show why the degree of freedom values for the ANOVA for the first one are 3 and the second one's 24. So this particular explanation, again I'm just going to type it for clarity's sake, the degree of freedom values, or DF values, are the first degree of freedom is equal to the number of groups, G, minus 1. And the second degree of freedom value, so DF2, that's the total number of every object in all the groups minus the number of groups, where capital N then is the total sample size and lowercase g is the number of groups. Then for how large an F statistic is needed to get a p-value of 0.05 in this ANOVA, this uses an F test. And in Excel, this is going to be is equal to f dot inv dot rt of that p-value 0.05, the first degree of freedom, which is 3, and then the second degree of freedom, which is 24. Typing this directly into Excel that I have over here on the right. Let me just, wrong direction. Let me just make this a bit bigger. So equals f.inv.rt of 0.05, 3, and 24. This gives us, nah, that's not the rounding that we want. 3.01 this rounds to. For that F statistic. For question number 9, we have here a recent survey of 1,000 American women between the ages of 45 and 64. Asked them what medical condition they fear most. Of those sampled, 58% said breast cancer, 8% said heart disease, and the rest picked other conditions. By contrast, currently about 3% of female deaths are due to breast cancer, whereas 32% are due to heart disease. And we first want to construct a 90% confidence interval for the population proportion of women who most feared breast cancer, and then of course interpret it. This would be our template for this. A bit bigger to see. So we were told that there were 1,000 American women, that being our sample size. And since we're referring to the confidence interval for women who most feared breast cancer, we need a percentage of 58%. So 0.58 times 1,000, this gives 580. That way we could see in this box that I just highlighted, that is 58%. So we need to construct that 90% confidence interval. So I'm going to specify this as 90%, and we are given a value we cannot read. There we go. It's 58% plus or minus 2.57%. So those values are going to be inside this green box. So let me type this out. We can be 90% confident that the interval 0.554 rounded to 3 decimal points to 0.606 contains the population proportion of women who most fear breast cancer. And then to indicate the assumptions that you must make for this inference to be valid, this would be that the data is obtained randomly. Not systematically, but randomly. The number of successes must be at least 15. And the number of failures must be at least 15 as well.